In this video, we're going to be talking about fractions and decimals, okay? And our essential questions. What are we going to be covering in this video? We're going to talk about what are terminating decimals, what are repeating decimals, and how are they written in math? How do I convert a fraction to its decimal equivalent? How do I convert a decimal to its fraction equivalent? And how do I compare fractions and decimals? So we're kind of switching gears away from our integers and into the world of fractions and decimals. So numbers that are not integers can be written in the following ways, either as a fraction or a mixed number or as a decimal. So if it's not an integer, it's going to be either a fraction or a decimal. So we need to learn how to handle these types of numbers as well. And then in the boxes here, I have examples of fractions and mixed numbers. And in the box on the right, I've got examples of types of numbers that are decimals. So you've seen these numbers before. So now we want to start working with operations with these numbers and how do we handle them. So types of decimals, first of all, there are two types of decimals. There are terminating decimals and there are repeating decimals. A terminating decimal is a decimal that ends or stops. So the root word here is terminate, and to terminate means to end or to stop. So you can see examples here of numbers or decimal numbers that are terminating. That means they end or they stop. So for example, 4.5 or 4 5/10, that number stops after the 5. The 5 is the last number in that number, so it does not keep going. Likewise, 1/10 is a terminating decimal. Here is 325 thousandths. That number terminates or stops. And then you can see other examples of terminating decimals as well. The other type of decimal is a repeating decimal. And a repeating decimal is a decimal that has an unending repeating pattern of digits. So if our decimal number keeps on going on forever into infinity, then that's a repeating decimal. So here we can see examples of those types of numbers. Here we have 0.3333333333, and this pattern would continue on and on forever unending. So this is repeating, not terminating. We can have more than one digit repeat, like in this example, 0.12121212. That pattern continues on forever. Here we have a digit that repeats after some that don't, 5.1666666. That one keeps on going forever. Here we have kind of like a mixed number that with a repeating part to it, 17.44444444, or 39.1818181818. So these are the two types of decimal numbers we need to learn how to deal with. So how do you write a repeating decimal in math? Because we can't just keep on writing these digits on and on and on forever. Well, we use what's called bar notation. And bar notation is using a bar or a line to show digits that repeat in a decimal. So for example, that digit that we had that repeated on our last slide, 0.333333, the digit 3 repeats. That's what repeats over and over again. So we can just write a single 3 with a bar over it, just like this, 0.3 repeating. Now I have some 7th graders that will write the 3 repeated and then put a bar over both of those. That is not how we write it. You only have to write the digit that repeats once with the line over it. So again, below here are examples of writing repeating decimals in bar notation. So 0.88888, we can write that as 0.8 with a line over it, a bar over it. Here's our 0.121212. Here the 1 and the 2 both repeat, so we have to write both digits with a line over both the 1 and the 2. And next we have 7.9999999. There, only the 9 repeats. We don't put the bar over the 7 and the 9, just the 9, because that's the only thing that repeats in this number. Likewise, 0.144444, we write that as 0.14 with a bar or a line written only over the 4, because that's the only digit that repeats. And then here we have 3 digits that repeat over and over again, 0.123, 123, 123, 123. So we have to write the 1, 2, 3 with a bar over all 3 digits. And then here is a long one that takes a long time to repeat. This one actually doesn't repeat until here. So we have 0.142857, 142857. So we do have to write out all 6 of those digits and put a bar over all 6 of them to show that that is a repeating decimal. So that's how you write a repeating decimal in math. We're going to use bar notation. So how do you write a fraction as its decimal equivalent? Because these non-integers can be written as either fractions or as decimals. So we have to be able to convert them from one to the other. So how do you write a fraction as a decimal? Top divided by bottom, or the numerator divided by the denominator. That is going to convert a decimal a fraction to its decimal equivalent. So here I have an example. What is 3/8 as a decimal value? How do you write 3/8 as a decimal? Well, 3/8 is equivalent to 3 divided by 8. We can think of it like that because fractions are kind of like division. We can think of it as 3 divided by 8. So how do you do 3 divided by 8? Here we're going to do this little long division here. So to do long division, 3 is like 3.0, so we can put our decimal right up in our answer here. 8 does not go into 3, or goes into 3 0 times, so we can put a 0 there. And now we can think, how many times does 8 go into 30? And 8 goes into 30 3 times, because 3 times 8 is 24. So we have a remainder of 6. Now, when you have a remainder, you have to keep dividing. So to keep dividing, we need more numbers. So the next number in the number 3 would be another 0. And 8 goes into 60 7 times. 7 times 8 is 56. And again, we have a remainder of 4, so we have to keep dividing. So we bring down the next number in the number 3, which is another 0. And 8 goes into 45 times. 5 times 8 is 40. So you can see that we no longer have a remainder after this, because 40 minus 40 is 0. So we're done dividing once we no longer have a remainder. And here is our decimal equivalent. So 3/8 as a decimal value is 0.375, or 375 thousandths. So let's take a look at some more fractions and see if we can write them as decimals. 4/5. So we think of 4/5 as 4 divided by 5. So we'll do 4 divided by 5. Now 5 doesn't go into 4, so we're going to extend our number here, 4.0. So it's going to go in there less than once. So it's going to be 0 point something, and 5 goes into 40 8 times, and 8 times 5 is 40. We have no remainder, so we're done dividing. So here is our decimal value. 4/5 is equivalent to 8/10, or 0.8. 7/9 would be 7 divided by 9. And again, 9 does not go into 7, so it's going to go in less than once. So we have 0 point something. 9 goes into 70 7 times. 7 times 9 is 63, with a remainder of 7. We have a remainder, so we keep dividing. Bring down the next 0. 9 goes into 70 7 times. 7 times 9 is 63, with a remainder of 7. So you can see now that we keep getting a remainder of 7 every time we divide. So this is going to continue, if we were to do this again, to be 7s. 7, 7, 7. This would never terminate or never end. So this ends up being a repeating decimal. So once we see that we're going to get a repeating decimal, we can go ahead and write that in bar notation. 7/9 is 0.7 repeating. Here we have a mixed number, 4 and 7/12. Well, I know that this is going to be 4 point something as a decimal. So now I need to just figure out what 7/12 is as the decimal portion of this mixed number. So I could think of that as 7 divided by 12. And of course, 12 doesn't go into 7. So it's going to go in less than once. So it's going to be 0 point something. 12 goes into 70 5 times, and 5 times 12 is 60. We have a remainder of 10, so we have to keep dividing. We'll bring down the next number in 7, which is a 0. 12 goes into 100 8 times. 8 times 12 is 96, with a remainder of 4. We have to keep dividing if we have a remainder. Bring down the next number in 7, which is a 0. 12 goes into 40 3 times, and 3 times 12 is 36. Again, we have a remainder of 4. Bring down the next number, which is a 0. And 12 goes into 40 3 times. 3 times 12 is 36, with a remainder of 4. Now, hopefully we can see we've gotten a remainder of 4 3 times in a row now. So this is again going to keep being a 3, 3, 3 over and over again. So that 3 is going to be repeating. So I know the decimal part of this number is going to be 0.583 with a bar over it. That's going to be 583 repeating. So 4.583 repeating. And that's how we convert fractions to decimals, top divided by bottom. So how do we go the other direction? How do you write a decimal as its fraction equivalent? Well, there's 3 easy steps here. We're going to read it, write it, and reduce it. So what does that mean? So let's take a look at this example. What is 8/10 as a fraction, or 0.8 as a fraction? Now we're going to read it, and we're going to read it like we should read it, and that's using the place values. And the 8 is in the tenths place, so we would read this number actually as 8/10. And if you read it correctly, that pretty much tells you what the fraction is, 8/10. So that's the write it part. So we read it as 8/10, then we write it as a fraction, 8/10, and then we have to reduce it or simplify it. 8 and 10 are both divisible by 2, so if we divide them down, we get 4/5. So 0.8 or 8/10 as a fraction is 4/5. So let's take a look at some more. Write these decimals as fractions or mixed numbers in simplest form. So this first number, 0.85, that's not how we read it. How would you read this number? Well, the 5, the last digit of this number, is in the hundredths place, so we would read it as 85 hundredths, and then we would write that as a fraction, 85 hundredths, and then we would reduce this or simplify this fraction. These are both divisible by 5, so 85 divided by 5 is 17. Whoops. And 100 divided by 5 is 20. So this is 17/20ths as a fraction. 85 hundredths, or 0.85, is 17/20ths as a fraction in simplest form. Next one here, we're going to have a mixed number. This is 3.44, but if we read it correctly, it's 3 and 44 hundredths. So that's what we would write, 3 and 44 hundredths. And then to simplify this, or reduce this fraction to its simplest form, these are both divisible by 4, and we would get 3 and 11/25ths, and there is our answer in simplest form as a mixed number, 3 and 11/25ths. Up here we have 0.7, but if you read that correctly, it's 7/10ths, and actually that is already in simplest form, since nothing divides 7 that divides 10 as well. So there's our simplest form, 7/10. We don't have to reduce it. And then the last one, 0.125. The correct way to read that would be 125 thousandths. So we're going to write that 125 thousandths, and then we reduce that. Actually, these are both divisible by 125. And we get 1/8. So there is our fraction in simplest form. 125 thousandths as a fraction is 1/8. So read it, write it, reduce it. How to change a decimal to a fraction in simplest form. And then lastly, how do you compare fractions and decimals? Well, if you have a mix of numbers that are represented as fractions and some that are represented as decimals, let's just convert all of the numbers to their decimal values, and then we'll compare the place values. It's much easier to compare decimals than it is to compare fractions, especially if the denominators are different. So that's what I'm going to do here. 2/3, if you take 2 divided by 3, you get 0.666666, so repeating. So that's 0.6 repeating. 0.6 is already a decimal, so I'm going to leave that alone. 4/5, 4 divided by 5, if you do that, you get 0.8 or 8/10. 5 divided by 6, if you do that, you get 0.83 repeating, only the 3 repeats. And then these other two are already written as decimals. So now I'm going to write these. 0.6 repeating, I'm just going to write a few digits of that out. 0.6, that's like 0.600. Whoops, I don't need another decimal place after that. 4/5 was 0.8 or 0.800. 5/6 is 0.83 repeating. That continues on. 0.65 or 0.650, and 0.7 or 0.700. So now these are all written in decimal form, so now I can compare their place values. There's nothing in the ones place, so now I look to the tenths place, and here I have 6s, 8s, a 6, and a 7. So I'm looking at the ones with the lowest values, the ones with the 6s. These 3 have 6s in the tenths place. Which one of them is going to be the smallest? Well, I would have to look at the hundredths place. This has a 6, this has a 0, and this has a 5. So this guy right here is going to be the smallest. So 0.6 is the smallest number in this set. So I've got that one taken care of. The next smallest one would be the 0.65, because that's a 5, and the one on top is it has a 6 in the hundredths place. Then the 0.6 repeating would be the next largest one, which was 2/3. And now the only ones remaining have an 8 in the tenths value or a 7 in the tenths value. So this is going to be the next largest one, 0.7. And then the 0.80 is going to be smaller than the 0.833. So that was 4/5. And then the largest number is the 0.83 repeating, which was the 5/6. So here I have all the numbers listed from least to greatest by converting them to decimals and then comparing them by using their place values. So that is what we need to know about fractions and decimals.